Hello everyone, this is chapter 3, Decision Structures and Boolean Logic. This chapter typically takes a while in class, and for somebody who sees this for the first time, be ready to practice quite a bit to become proficient with it. There is always a part about understanding abstract parts, such as what is Boolean logic, what are the statements that are evaluated true or false, and how to use if, elif, else, or just if, else, or nested if, else. So all of that is addressed in this chapter, and all of that requires some experience, and after you have done a few problems by yourselves, go back to the actual theory and you will understand the theory better. All right, here is where we begin. So a quick overview. We're going to talk about if-else statement. If by itself, if condition, then do something. That is the way, the most basic way that Python could work. Or if-else, and we will also talk about if, elif, else. So to understand if-else statements, we will need to talk about logical operators and Boolean variables. And also a quick thing about comparing strings. It does not come up very often, however it is useful and I do encourage you to know about it. Last but not least, we will talk about turtle. Turtle is a fun little thing where you can do something like operate the turtle, tell it to dive or tell it to move and trace, and use it to graph some interesting shapes. With time, you will see some interesting shapes there. Turtle will come up in the quizzes, I think, for chapter 3, chapter 4, possibly chapter 5, I think chapter 5 as well. It's not really something that people use for practical reasons, but it is something that will help you to start thinking more like a programmer. Turtle requires good planning, and by all means, look at the book examples of Turtle and also check out one of the videos. It will be dedicated to Turtle. And yes, we will see it in upcoming chapters as well. All right. So generally, we would want to see structures and describe those structures in terms of flowcharts. This is a basic flowchart. Diamond will stand for a decision, a place where decision is made, and decision will return evaluate to true or false. And depending on true or false, another statement will be executed. So cold outside evaluates to true, then wear a coat. If it evaluates as false, don't wear a coat. This is not like programming structure yet. This is like a human decision structure, but this is very good for your intuition. This is about as basic an example as you can have, and also it does help you to understand what's going on later. So let me go back a little bit. So in general, control structure is a design that controls the order in which the statements execute. So far, we have seen only one design, sequential design, that is statements are executed one by one, and every next statement has to be executed before the next one. Okay, so decision structure. Specific actions performed only if condition exists. So, for example, if it is cold outside, wear a coat. It is also can be thought of as selection structure, such as if it is a work day, go to work. If it is a weekend, then you can chill. So this is a decision structure, but it can also be described as an if-else structure, decision structure. All right, so in a flowchart, we will see diamonds. Diamonds will be the places where decision is made, and it will be evaluated to true or false. And That decision will be a Boolean statement, and the result true or false are the typical how usually the mathematical logic works. So mathematical logic takes some is working with some formal mathematical expressions, and they evaluate to true or false. So we can talk about conditionally executed actions. Those are executed if condition is true. And as I was saying earlier, this is the most basic decision structure. We're checking code outside. If it returns to true, if it returns true, then where a code, then go about your day. So there may be many other things to do during your day or program, and there could be something to do before, but this little structure is deciding whether or not you need to wear a code. And if code outside evaluates to false, then just go on about doing whatever you needed to do next. All right, in Python, if condition, then statement, statement, statement. For example, if condition that evaluates to true, code is true, then wear a coat, wear gloves, wear a hat, and so on. So condition is where the Boolean expression will go, or where we put a Boolean expression, and I will still have to explain what it is later. So condition is something that evaluates to true or false, and condition has to be tested if condition, then indented block of statements. So indentation matters. If condition is false, then it goes to the next unindented statement that you cannot see in this example. So these two statements will only be executed if condition is true. Okay, so Boolean expression. Now going about Boolean expressions, this is something to evaluate to true or false. This may be this may seem to be very superficial and very binary, but you can do a lot with it if you master the Boolean expressions. You can do a lot more than simply deciding between two actions or deciding, for example, what is bigger than in between two values. So A bigger than B is either true or false. If we're talking about numbers, then it is either true or false. If we're talking, for example, about integers. And there is an operator in between. Look back at the previous chapter. If you forgot about operators, plus would be an operator. In this case, it's bigger. Bigger is an operator. So that is the one that is evaluating the expression. So this is one such expression. Besides that, bigger or equal to, smaller than equal to, in the same way, they have the same meaning as math operators. And notice double equality sign. Double equality operator is for checking that something on the left is equal to something on the right. And it may be a good point for me to start idle and show you the difference between two things in idle. So a equals 5 sets a to be equal to 5. And a double equal to 5 returns true. So double equality is checking whether or not a is equal to 5, which it is, or if I now checking a is equal to 6, it's false. Very similarly, let's check that a is greater or equal to 5. Think for a second what it should evaluate to. The answers are only binary, true or false. So do you think this is true or false? Well, in fact, it is true. A is bigger or equal to 5. I will talk about or a little later, but this is something that hopefully you know from math. So this is indeed true. So a equals 5 satisfies this inequality. It's a non-strict inequality, bigger or equal to 5. A is bigger or equal to 5. So 5, A equals to 5 does satisfy this inequality. All right. Not equal to is another operator that determines whether the value on the left and value on the right are different. Okay, let me try a not equal to 5. Think what will this evaluate to? It will evaluate to false because A is actually equal to 5. Let me check. Oh, sorry. A equals to 5. True. All right, so this is a Boolean. As opposite to that is an assignment. Boolean is an expression that checks a condition, evaluates to true or false. All of these are rather basic Booleans. Okay. So this is a full table of them. Maybe I'll go to full screen again. So x is bigger than y, same as in math, and less than y, bigger or equal to, and for this Boolean to be evaluated as true, one of the conditions should be evaluated to true. And finally, double equality. That is a new thing, not something that you have seen in math. This is a notation for checking if x is actually equal to y, and exclamation equality means not equal to. Shortly, we will see a bunch of examples how to use that, and we will be using that. All right, before talking about any complicated examples, let's talk about this decision structure. So using Boolean expression to evaluate whether somebody gets a bonus. So let us reverse engineer a story problem out of this decision structure. So this is checking if sales is bigger than 50,000. If that evaluates to true, then bonus equals to 500. Otherwise, continue with the program means there is no bonus. So it's easy to reverse engineer a problem. So we want a little program that will decide whether a person gets a bonus, and the person gets a bonus only if sales is bigger than 50,000. So let us create this in code. So I started a new program. I actually want to close the idle. And what I'm going to do, I'm going to, first of all, try to literally recreate this decision structure. So if sales bigger than 50,000, and in the meantime, think what I'm doing wrong or what else I need to do. My print statement will be you get a bonus. $500. Do I need anything else? Think about that for a second, and well, it depends. If this was a part of a bigger problem, if there was something before and after, I might have not needed to include anything because literally this decision structure is implemented in this code. If sales is a variable bigger than 50,000, then you get a bonus. And just to be more literate about the bonus here, more literal about the bonus here, I need a variable bonus equals to 500. That's what this little box is about. However, if I try to run that, it will return with an error message. Guess why? All right, that is something that we should have thought before we ran this program. Name sales is not defined. So variable sales was used here in this Boolean expression, checking that sales is bigger than 50,000. However, the Python does not know what sales is, and somehow we have to define it. Now, a cheap way to define it would be sales equal to 30,000 or 3,000, 30,000, okay. And okay, just for an example, let's make it 60,000 so that we see some printing statement. And in that case, the program will work. You get a bonus. Sales value was 60,000. But say if sales is 50,000, then you get your whatever the printing statement is. And then you also have the variable bonus, which is 500. The program works now as intended, or so it appears. However, it is slightly meaningless. So if we look back at this decision structure and try to reverse engineer this story problem or the reason to have this problem, then this does not seem to be very reasonable to ask a user to go to the py file and change this number every time. So pause the video, think what you should do differently. All right, I want the user to say what are sales. So every time the program runs, it will give a different value. Or it will ask a user and user can give a different value rather. Now, look at this, and maybe at this point you are already yelling at the screen and saying that something is wrong. If not, think about this. I'm going to run this again just to see what happens. Okay, did you spot an issue? Let's see. Enter sales. Let me put in 64,000. Error. Type error. Bigger. The operator bigger than is not supported between string and integer. Think for a moment what it means. It means that I'm trying to compare a string to an integer. Where is an integer in my program? 50,000 is an integer. Actually, let me go back to idle. If sales 50,000, this is where the problem is. And the problem is string is compared to the integer, and there is no meaningful way to do that. At least it's not realized in Python. So this is a string. This is a number. Comparing string to a number, that's a problem. However, the remedy to that, what I should have done from the start, is convert the result of the input. Again, look back at the previous chapter if you need to. Before sales will be a number, I should be converting it to a number. So second attempt to do this problem. Now sales, first of all, we ask the user what the sales is, what the amount of sales is. Then we convert it to an integer. And finally, this is a variable sales. Everything will work, right? Enter sales. My sales will be 60,000. You get a bonus 500. Yay! If we try bonus variable, which was created in code over here, we will see that it is indeed 500. And again, everything seems to work. My question to you: what can possibly go wrong? As a programmer, you should at least spot such things and make decisions about it. So what can possibly go wrong? If you cannot figure it out, we can actually restart the idle. I want to restart the idle to start clean. So enter sales, I'd say $52,123.12. Will it work? Nope, it won't. Invalid literal for int. So this is a string that I entered. It cannot be converted to int because this is not an integer number. So if you want to think about it, sales don't have to be a whole number. It can be so many cents. So my sales should not be int, it should be float. And now my program is a little bit more stable to this kind of issues. So 54,000.12 cents, and it's handled with no problem. Now, can you think of other issues that this program has? And that is, again, I'm showing you testing and debugging and improving your program accordingly. And this is really the crucial appearance. Not much time goes into typing up this code once you understand it. So you spend time designing this code, and then you spend time testing and debugging and improving it. And those are the two things that are most time consuming, and they should be for you, especially as a beginner. That should be something for you to work on. So here is a problem that may be not obvious for beginners. 42,000 is my sales. Nothing happens. It does not mean that the program did not run. It means that, well, there is nothing here to run. If sales is bigger than 1,000, sales was sales is bigger than 50,000 is my boolean. And when sales is 42,000, this evaluates to false, and hence this indented code is not executing, and hence the program is done working and it does not produce any output. That is not very good, and you should be thinking how to improve that. And of course, the remedy would be else. One of the remedies would be else. Or just the simpler remedy would be unindented print. Do say the program is done, so that we at least know that the program actually did work out okay. So 42,000 done. So that is obviously not good enough, and a better way to do it, I'm introducing else here. Else covers all other cases. Whatever was before, if, elif, else statements, there can be a bunch of elifs. If something, this something is false, this boolean turns out to be false, then the else part is executed, print. You don't get a bonus. And also, since I defined variable bonus to be 500 in one case, in the other case, I should define it as well, because maybe I will use it in some computation later. So that would be better programming, I suppose. So bonus in that case is 0. And color coding already is telling us that I did something wrong. Do you remember how to remedy that? Well, look back at the last chapter. Escape character will help. So now my program will print something meaningful either way. So my sales were below the threshold. You don't get a bonus. And last little bit, it may be not great to have naked constants appearing in the middle of your code, and we will discuss later how to improve that.